Welcome to the Metal Building Show. My name is Eric Beavers. I'm the owner of Great Western Building Systems.
My name is Jared Miller. I'm the chief detailer here at Great Western Building Systems.
And I'm Justin Larwick, the media geek for the company.
You are a geek, dude.
Seriously.
All right. Oh, and remember, turn down. We can, chats will show up on the screen now. So, welcome everybody. Sorry, Justin's having all sorts of technical difficulties over there. Can't get his internet working, and then I was wound up on a phone call with a customer talking about us providing details for his ceiling attachment. And his builder is like, well, we don't do wood details for like your interior framing, but we did the collateral loads. And here is a letter sealed by our engineer. And he's like, now the building authority wants details. And I'm like, well, you have architectural plans. Those are the details. And anyways, I think Dan or Richard has to get on the phone with his architect, because they should be approving that and verifying that it does not exceed the loads designed into the building, which it won't. I mean, it's easy, but it's Maricopa County, Phoenix, which has been a thorn
for a long time
in our side for a long time, right? It was Vegas for a long time. It used to be the whole state of California. California's gotten easy, man. Right?
Remember at one point, I remember in my career, Miami-Dade was the dreaded one. It's like, you don't want to build there. It seems like they've kind of relaxed too. It's like, oh, we've done stuff. Yeah, it went up without a hitch. It was great. You know?
Yeah, but Miami-Dade was just about the wind-blown debris region, right?
Mm-hmm.
Mostly. They wanted like all of the testing reports on the panel for like the missile test, right? And basically the missile test is where they test the panels like on certain spacing. They load a 2x4 up into an air cannon and fire it at like 100 miles an hour, and it's not supposed to penetrate the building. And that's why 24 gauge is required there, right? It's a thicker material, but it's a softer material. So it dents in, but it doesn't break. Where the harder, tougher steel is more dent resistant, I believe. I don't know. Me and Jeremy, one of our project managers, was arguing about this the other day, reading over some technical documents. But the problem is they're more dent resistant, but once you put enough force, they can split under impact.
Fascinating how that works.
It's amazing, right? Yeah. Oh, hey, you want to see something cool?
Yes.
Well, let me see if I can reach. It's fucking heavy.
Yeah.
Guess what this is.
Justin, you go first.
I'm actually waiting on a delay. I'm actually watching the video on our YouTube because it's frozen on my end.
I think that is a 1.5 B deck.
It is a 1. It's a B deck.
Oh, okay. Here we go. Is it 1.5?
SOB, man. It's a 1.5. Good job. Now, what gauge is it?
Nailed it.
Oh. Somewhere between, I would say, 20 and 30 gauge. Somewhere in that range.
It's either 20 or 18. I don't know.
Okay.
I like how you didn't know the answer.
I could get the micrometer out of the out of the shop. The super
maybe that's what
for testing.
We should put that in the comments. You know, we'll acknowledge you if you can guess the gauge correctly.
Right. Okay, so
how's the CRU?
I don't talk about CRU these days. Actually,
that's an answer in and of itself.
The CRU, maybe this will help. There is the CRU. Oh, look, it did all of this drop yesterday. So what, it went from 880 yesterday to 860, which was, I think, or 858. So it's $15 a hundredweight. I did the math. It was 7.5 cents per hundredweight, which this looks like a big drop, but let's keep in mind here that takes, my costs on raw hot roll coil, right? Which is just really a benchmark from us from, after mill stuff from, well, really, I mean, 60, 65, closer to 70 cents a pound on some products to say it's 70 cents a pound on some products right now. That drop will now make that steel cost, that's 100 weight, so 100 pounds, which I don't know why the industry does that. It's just stupid, but it's the way we think about it. So now it would be, instead of $70, it'd be $69.85 for 100 pounds. Hallelujah.
There you go.
But here's what's interesting. I think that you can see these drops, right? You can see these drops, right? This is what steel does. The steel comes falling down, the mills get pissed off, and they jack it up. It's like a cabal. Here in the earlier part of the year, or early part of the summer, it was this is last year. This was tariffs, bang, mills take full advantage, comes down, demand's just not there, even at the pathetic capacity that the U.S. mills are running at. Now, of course, I mean, the mills are running at 78% of nationwide capacity. But we have to keep in mind that is still more capacity than what we had 5 years ago, right? With the SDI Sinton plant coming on, with the big Nucor expansions in Tuscaloosa. I think they did a giant, either Tuscaloosa. I don't think they upgraded Blytheville. The Blue Scope plant out at North Star, giant improvements there. I mean, double the capacity of that freaking place. Cliffs has increased. All these big plants that have come online. These are not Great Western size operations, right? These are 1,000 employees in the shop type operations, or even more operations. So I mean, capacity is there. So it looks like the mills. But I guess what I'm trying to get at is that the mills artificially inflate domestic steel prices. You'll never convince me otherwise. Stamped it. It's true. They want the record profits, which they owe to their shareholders. I'd do the same thing if I was a steel mill. I mean, the problem is there's no competition in U.S. steel. You have SDI, you have U.S. Steel, which doesn't make any of the heavy iron, right? None of the structural stuff, right? They're just a coil and a sheet producer, right? You have Cliffs, Steel Dynamics. Steel Dynamics, great company, right? But really, I mean, in our industry, it's either Steel Dynamics or Nucor, right? Those are the only two options. Well, I suppose Gerdau in a way, but Gerdau is like Merchant Bar and Wide Flange. We buy a lot from Gerdau, but if I was one of those companies, I'd be like picking up my phone, on the secret bat phone, talking to the CEO at the other place, like, "Hey, man, what are you thinking?" All right. I don't want to lower prices. That'll bring up demand. Or lower prices will bring up demand. I'll have to hire more people. How do we just sell this shit for $200 a pound and have 10 guys working in here, right? I don't know. All right, I digress. This is getting out of there. Okay, so far today. Aaron Cowdy, him and Ty and Jake, they are just buried in the yard. God bless those guys. They are working, so he could not take the time today. And then actually, as soon as we get off of this, I have to go into the shop because we have that big, that giant job that's being galvanized, Jared.
Mm-hmm.
So we got these 1.5 inch holes or 1 and 9/16 holes that have to be punched in that 1x12 connection plate. I think it's 286 holes or something.
Yeah.
What job is this? I'm not.
I don't talk jobs on the thing, but 95386. If you want to look it up, it's nasty. And it's being galvanized, but
sounds epic.
We can punch it, but the machine is tearing up the plates, right? It's probably tearing up the machine too. So we're having that bowing thing. So we don't have time to take the plate line off down for 4 hours to recalibrate it and go in and do all of that stuff. So as soon as we're done here, I'm running out to the shop with all of the paint prep and running mag drills for the rest of the day. The things we do to get people their buildings.
Remember that absolutely massive arena that we did a couple years back?
City of Grants, New Mexico.
Did that ever get wrapped up as far as like
Yeah, it's
their
done.
construction side?
Yeah, it's done. It's put up. It's huge. It's definitely the biggest clear span that we've ever done.
That thing was truly huge. Seeing the members, like the primaries go through the shop was like, it was monolithic. Those were huge.
You could stand inside of the webs. Yeah, 72 inch webs. I'm 5'11" and 3/4.
Yeah, that was the biggest I've seen. That was nuts.
I think I'm actually
we can shoot that. I should go out there and see.
Yeah,
I can fly a drone around it because that was pretty amazing.
They're friendly. What ticked me off about it was the delivery date that they wanted was between, what was it, Jared? Between
it was
the 15th of December and the 1st of January.
Right.
And of course, we signed the city's contract, not, they didn't sign our contract. And it was like 30 trucks or something. And so we had liquidated damage clause in the contract for, I think it was just $1,000 a day, right? But it wasn't specified business days or anything like that. And now liquidated damages, for anybody that's looking at this on a contract that is of the essence, that is there to cover on-site costs, lodging, crew expense, whatever. Usually it's about $1,000 a day, for an erection crew or something like that. I've seen other contracts with bigger penalties. And so because it was Christmas, we had everything there except for like 6 trucks out of this whole thing. It's all delivered on time. Some of it was going to be early on some of it because we had to ship it to get it out of the yard. But they stopped work the week of Christmas through the 2nd, right? I think they came back on the 2nd or the 3rd, or maybe it was the 4th or something, right? Boom. You can't deliver anything, right? So we couldn't get all of the trucks to them before that because we just can't get that. There's a minimum number of trucks. There's, a maximum number of trucks that we can load. Also, it was the damn holidays. So finding a truck driver is not exactly easy. People want to be home with their family. So we weren't able to deliver it. It was 10 days. We didn't get the last truck there until January 10th. Right. And of course, after all the truckers go home and stuff, then they all got to, drive out to their job sites and stuff. It was four things. Anyways, they did not put that building up for over a year and a half after it was delivered. And they nailed me $1,000 for every day on the contract. And I talked to the accounts person over there and was like, guys, this is unfair, right? This, give me a break, right? Like you have and they came back and were like, no, the mayor says the contract's a contract. Like, contract's a contract. All right, fine. Yeah. And then I was like, hey, it should only be, business days, right? And they're like, contract's contract. All right, I'll send you a check for $10,000.
Man, that's.
But anyways, it is an
business as usual.
Jared Miller, the man, detailed that.
Yeah,
nice.
Yeah, it was
kind on the ground for a year and a half.
Mm-hmm.
That both doesn't surprise me, and also like, man. Well, I guess it's their business what they do with it after we send it to them.
Yep. It's not like they had permitting problems.
Right. One of the few jobs.
It doesn't get hassled for permits.
Yeah.
Like, oh no, it's the city project. Mm-hmm. Okay. So 15 minutes in, I haven't talked about a thing. Standing seam roofs. Let's talk about roofs.
Yeah.
I'm still sharing the CRU screen here. Sorry about that. You guys with me?
Yep.
Yeah.
All right. Now it's time to actually talk about something specific, and we all clam up.
No, that's. I think they're a big topic. Roofs. They cover a lot. Cover a lot of different things.
That was a terrible dad joke.
Yeah.
What covers a lot of things?
Roofs.
It's an awful joke. Awful. And
I'm gonna go drill holes. I'm gonna go.
Everyone just clicked off the channel. I'm like, all right, no.
Okay, fine. Then
Jared
I'll go.
Miller calling me the hour.
Right. You guys hassle me because I was watching the interview with the docs. Man, I can interrupt people. Like, I'm worse than Ron Avey, man. Well, maybe not that bad. So
that interview is pretty great, actually. Right. I enjoyed watching it.
Hey, Tim, just in case you see this, I did finally wear your shirt. Thank you. It's actually a really nice shirt. It's a Dickies shirt.
Nice.
Yeah. I've never worn Dickies clothes. Okay. Now we're talking about clothes. Roofs. Okay. Two types of metal buildings. There's generally two types of metal building or metal roof systems, right? Through-Fastener systems, which have a variety of different panels, or standing seam roof, which in our industry, or at least for, a company like, commercial metal building systems, you usually have a 24-inch trapezoidal, which is a commercial or a industrial, low slope, standing seam roof, or you have the architectural, which is a 16-inch, 2-inch vertical leg. Really nice. And okay, cool. That's wrap.
Well, and it sits on with the standing seam too, right? It works off of clips, right? And those clips, they have basically a sliding mechanism that helps all buildings, once it's experiencing what we'd call like a load, right? It moves, and that sliding clip system helps that building expand and contract more easily, and it doesn't tear up essentially the building when it's experiencing that load. So
right.
Go ahead.
See, I'm interrupting.
That's all right.
I just can't.
We're just conversating.
I was thinking, let's talk about the pros to a through-fastener roof system, a standard PBR roof system that you see on metal buildings out there everywhere. The same roof that is on Grants, New Mexico. We could talk about that in a second, right? Yep. When about the whole contracts are contracts, right? Because I desperately tried. I was like, guys, you can't do this, right? You can't put a screw down roof on a 140-foot slope, right? It's a 140-foot roof, 140-foot roof, right? You can't do it. It must be a standing seam. And they said, no, it doesn't. Like, well, I guess technically you're right. It doesn't, but contract. That roof will leak eventually. And the reason why we're talking about thermal expansion, Jared.
Mm-hmm. Yeah. So like I said, the building is experiencing a load, and when it does that, it starts moving. Well, because essentially the fasteners with a screw down roof, right? It's so rigid that once it starts swaying back and forth, the weakest material has to start deteriorating. Well, what essentially that is, in a big enough scenario, and it's got to be a fairly big scenario, is the sheeting. The sheeting starts kind of tearing, and what you'll see is like the holes start wallowing out, and now you've only got, like on Grants, New Mexico, if memory serves correctly, that was only for that roof 10,000 screws went to hold down that roof. So that's it. It was
only 10,000.
What? No,
no, it had to have been more.
No, it was 100,000 screws.
It could have been 100,000 screws.
Right. I could pull it up and look, but
yeah.
No. So thermal. Hold on for one sec.
He's got to get checked. Oh.
Sorry.
No, it's okay.
The average customer is going to hear 10,000 and be like, that's a lot. But
yes,
it's not. It's not. There's 10,000 screws on a 50 by 100.
Really isn't.
Yeah.
Okay, so I'm talking about thermal expansion, right? So one of the problems that, and there's lots of documentation on this, and it's kind of intuitive, right? I think over 100 feet, a 26 gauge PBR panel, I'd have to look it back up, but it's like in a 50 or a 60 degree swing, that panel will contract. I think it's over 30 feet, actually, 33 feet. Anyways, it's a much larger number than you would think, right? And what that does, because that roof is locked into that purlin system, all of that expansion is being held down by those screws, right? So the panel in between those screws is trying to expand, so it's going to bubble up or it's going to come down, right? That energy has to go somewhere. And what happens is, the screw holes, the panel eventually starts to wallow out those screw holes.
And you've got to factor in time here too, right? You're not going to put this up and, in the first year experience this. We're talking over 5, 10, 20, 30 years, right? This happens, right? Yeah. So it's you got to look at the long game.
Yeah, these buildings are designed for the long game. They're supposed to be, lifetime long.
See, Justin's covering our ass here. He's like, well,
it's true. They're like 40-year buildings, 60-year buildings. I mean, people have these things for 100 years. Like you want to think ahead.
Well, if we want to talk about theory on this, so MBMA, which we subscribe to, or at least their thoughts. I don't pay the MBMA. I'm not qualified to be an MBMA member because I got to give them a lot of money, and I would rather buy better machines than And they don't. The Metal Building Manufacturers Association, they don't want Great Western in there. That's Nucor, that's Blue Scope, that's Volcraft, that's Varco, that's Chief. Even SBS isn't a member of the MBMA. That's one of the largest
suppliers.
Yeah, one of the biggest factories. They are not. Why would they be? They don't need to be. Anyways, so the MBMA is just a conglomeration of metal building manufacturers that get together and they come up with the rules that kind of loosely govern our industry, kind of as a club thing. So we do follow the MBMA guidelines, but we're not going to, thinking about Nucor Building Systems or Butler, right? Jared and I aren't going to. They'll kick us right out of that meeting. They'll be like, you dorks, leave. We're doing math. Anyways, this show is going to hell in a handbasket. So I think their recommendation, depending on the climate zone, is slopes over 35 feet should be standing seam.
No, I think it's higher than that. I think it's up to 120. Anything over 120.
Okay, now that we're talking about thermal expansion, well, before we move on to standing seam roofs, though, with the thermal expansion, it's always been an interesting thought to me, Jared, to think about the time of year, the time of day, the current temperature, or the current temperature of the panel in the sun while you're installing it, right? So if you're installing that panel on the coldest day of the year, right? You're in North Dakota. North Dakota would be a great example, right? Or Minnesota, right? Where people think, oh, it's the Great White North. It's cold. No, it gets hot there, right? And sunny. So coldest day of the year and it's cloudy, right? Those panels are as small as they're ever going to be. And you install that roof, all that expansion now goes into play. So really what you'd want to do is install it at the perfect mean, right? Or the perfect average of what that panel would get, right?
Experience, yeah.
But then you factor in sun and how that's going to heat up a panel. It kind of gets a little bit complicated, but I've always thought about that.
Yeah, it is an interesting.
Yep. So install your metal roof panels. I suppose the same thing it'd be true about walls too, but I mean, you don't get, 100-foot walls. Install on the hottest day of the summer, but at the coolest time in the middle of the night on that day.
I'm sure some OCD erector has done this.
I doubt that. Okay. All right. So the floating clip, Jared, that you were explaining, that absorbs that expansion because the roof floats. The roof panels actually slide on that clip system, unless you're using unless it's a short span, you're using a utility clip, or what do we call that, a fixed clip, right? I don't do that very often.
Right. And that would be, if you were using that fixed or utility clip, that would be more of a, like Eric said, just a short span, or I'm really going for the look of an architectural roof. And I would say something where you're going to see the roof slope, right? If you've got, I would say anything 3 to like a 12 on 12, you're going to see that roof. And it's, if you had like a 12 on 12, it's almost going to look like a wall. So you want that panel profile and you want that look, but you don't need that functionality of the sliding back and forth to handle the expansion and contraction of that. But yeah, that's, like Eric said, that's when you would want to use those.
Another thing with, so PBR, back to a through-fastener roof, right? I mean, the biggest pro to that roof system is cost and labor, right? That's going to be the most cost effective. And for me, as an erector, the easiest to install. Now, there's other erectors, like the big companies, in my experience, that would much prefer to install a standing seam roof, because that's what they do, and they got it down, and they can knock those things out, right? And especially if it's being insulated, there's not as much compression of the insulation with the screw, because the high floating clip can come. What's the height on a high floating clip? Like 2.5 inches above the purlin?
Yeah.
Or 4?
No, it's I think it's 3.5. Yeah.
2.5. Okay.
3.5.
And they can just rock those things out.
Eric, the standing seam roof like that, why is it easier for like the big crews to do it? Is it just practice? Is it just they have better tools, or what's the deal?
Because you're not running around. Once you have your clips in place, right? It's like 2 screws for clips. They can snap a line. Once those clips are in place and the other panels installed, they just carry over the next panel, throw it down. It nests on the far clip and loops over the, it hits the seam. They have the hand tool, and they're usually drill operated, where it just compresses the clip that just got the double nest, or the double panel, crimps that, and bang, they're done. There's no more going in, doing screws. There's no more going in and doing stitch screws. There's no mastic. Mastic's pre-applied to those panels generally. And then they just run their seamer, an electric seamer, which we'll talk about in a moment, but they just zip, run it up, run it down. And they just, where erectors that aren't so installing a standing seam roof as an erector the first time, which I have never done, in my impression of it is it's a lot like the first time a brand new guy goes out who's never erected a building and goes out to install a building as an erector, not as an end user, right? End user has time. And you don't know what you don't know until you're doing it, and you can butcher those jobs. Right. And really it's about reading the plans, getting the layouts correctly, right, Jared?
Yeah. Yep. Following the plans, following the details, along with the erection guides that are provided as well to help stage that stuff. I think even like with a PBR roof, what's the most important panel that goes on?
The first one.
The first one is the one that you spend a lot of time on, and
the last one, because then you're done. A very important panel.
Yeah, that could be. Okay. Yeah. But, starting that first panel, getting that laid out right dictates the layout of the rest of the roof, right? And, putting that on there correctly, getting that laid out, getting it squared up, that will dictate how the rest of that's going to go. If that one's put on crooked or wonky, or we didn't get all the screws in, it starts showing. So it takes time, laying that out. But then once you do, you start building up steam and stuff like that. It's a learning curve. It's a slightly different, product and process. But yeah, there's generally training with that too, especially when you think about weather tightness, right? Because that's one of the real things that you get into with a standing seam is that it could be you can get a weather tightness warranty, which especially like with large scale commercial projects, they really want that, and that helps with insurance costs too, from what I understand.
Mm-hmm.
So,
yep. So hopefully that answers the question there, Justin. But
and
weather tightness is on the list. I want to talk about R value and energy code, but weather tightness. Yeah, you don't get a weather tightness warranty on a through-fastener roof. And I've been queried on that, and the answer is, well, that's because you're putting holes in it intentionally. All right, sorry. But the I've considered maybe offering weather tightness warranties on our buildings, but it's going to be one of those things that it's absolutely not useful. Right. It'd be more of a sales gimmick than anything, doing a weather tightness warranty on a PBR panel, right? Because the list of things that the warranty could not cover or would not cover would be erroneous holes, improper installation, right? Hey, cool, your roof is leaking. Well, we just inspected it, and no kidding, your erector missed the purlin because he wasn't snapping or pre-drilling lines, missed the purlin 3 times, sunk two stitch screws behind it, and then gobbed a bunch of silicone over the top. Right. Eventually that's going to leak. You're going to have to go up there for the rest of your life and put down silicone on it, or do a cinch strap and actually fix it properly. But that would be, like that, or,
it
would always be
disingenuous.
Yeah. It would always be an install issue is the only reason why that roof would ever leak. Right. Unless it's a thermal expansion thing, which we're not going to cover. I guess the warranty would cover it to a certain length, but it's like the paint warranty. I guess I've only been at my level in the industry for what? Just under 20 years. And I've seen maybe 3 or 4 panel warranty claims, all denied, or paint warranty claims, I should say, all denied because the cause of the problem was actually not sweeping off the metal shavings after you installed the roof. Yeah. So it looks like rust is coming through.
Right.
But if you take a rubbing compound and rub on it, it's like, no, you left a shaving here. That's why it's everybody sweep your roofs at the end of the day and your walls. Okay. Back.
Yeah. That's important to bring up. How many customers do you think are sweeping the roofs after they're done?
Everybody should, right?
Everybody should, but how many do you think are?
A lot.
Especially the professional erection crews. I mean, they know.
Well, yeah,
they know.
That's a different question I'm asking.
Yep.
Should have specified.
No, I mean, a lot of customers watch all the install videos, and I've covered it a bunch of times. Then there's 2 reasons. I mean, always sweep your roof, right? It's never okay. I suppose no, because if you have here's what happens if you don't sweep your shavings. I mean, sweep your shavings after every panel that you install. As you're moving around on your knees on the roof, installing tech screw or stitch screws or other screws. Because if you're trying to bust out your roof, you're not going to install all the screws each panel, I suppose, unless you're working alone or something like that. You want to get that roof on as quick as you can, and then you can come back and fill all the screw holes. So you're going to be on your knees. And those shavings will get trapped in your pants or your knee pads or whatever you have, or even to the bottom of your shoe.
Yep, bottom of your work.
And if you have a dark panel, it's going to scratch the panel.
Shoes are an issue we should bring up.
Yeah. And then if you have a light panel, we talked about shoes in the last. Oh no, in Tim's interview, I talked about shoes. Yeah.
Yeah.
Yep. And then on a light panel, you want to sweep them because they'll discolor the steel, right? So if you have a black panel, nobody cares if you have a shaving up there that rusts and stain the panel. You're never going to see it. You'll see it on a white panel, a stone panel, a gray panel, well, maybe like a light gray panel. So, Jared. Okay, so a screw down roof is fixed at all locations, at every purlin line. a standing seam roof has no penetrations with screws except for except for one end, right?
Correct. Yeah. The main thing that with a standing seam roof, the idea is at the low eave you have what's called an eave plate, and you'll attach that to your eave strut, and that is where you'll actually put screws um, to the eave plate. But what the benefit of that is, with the shape of that eave plate, and when you mount it to the eave strut, those screws are actually outside of the building envelope. So even if it were to leak, it's outside the building envelope. So that's not coming in and ruining your, the interior build out of your roof. There's still no fasteners within that area. And that's one of the main things that a standing seam roof does too, is like there are fasteners in it, but exposed fasteners, but they're outside the building envelope. So it doesn't matter.
Okay. Now thank you. I just learned something here because I knew that one end got fixed.
Yes.
And then everything
expands
in the other direction.
Mm-hmm.
But I know that there's two ways to do it. One is at the peak, one is at the eave. And I wasn't sure which way we detailed.
So we
detail at the eave.
We do
because it puts those penetrations outside.
Correct.
Oh, so the eave plate actually hangs on I always thought the eave plate came into the building. It actually goes out.
It does go.
Or it just comes up.
Correct. Yep. It lifts it up. It does two purposes, right? It does.
Right, lifts it up for the clips.
Yep.
It same height as the
clips. That's right. And then it also essentially turns those fasteners outside of the building envelope. So, like I said, you wouldn't have to worry about that. But yeah, and I have I've done some buildings where the spans are so big that you actually have to, in the middle of the roof, have a step joint, which is where you basically break up the roofs and install another eave plate in the middle of the roof to handle all that expansion and contraction too. Really, really big buildings. I mean, we're talking 600-800 foot wide kind of a thing.
Well, that would be okay. So understood. Now, what about so 50 foot is going to be about the absolute max on a standing seam, like something shippable, and you probably would prefer a 40 or who knows how it works out. But at the seam, we used to remember cinch straps? I mean, that's where I get the name cinch strap, but cinch straps really aren't used anymore. So how's that seam handled?
It's still seamed together. The same. I think what really changed with the cinch strap was really fastener technology. That's one of the things that I've really heard was, I mean, we used to do a lot of cinch straps in the industry. Trying to remember what year that was, 2010, maybe somewhere around there, that the whole industry essentially just got away from cinch straps. And I think that was really because of fastener technology.
So anybody that doesn't know what a cinch strap is, because I use the word cinch strap, my terminology can just be anything that goes underneath sheet metal, panel, trim, or whatever, that a fastener gets driven in, probably through two, in order to suck those together, right? And create, like if you accidentally have a hole in a panel where there is no purlin or anything like that, you don't want to punch a tech screw down there, right? Because it's just not going to hold up, right? The threads are not enough to bite into that thin metal. So you put a little piece of plate or 16 gauge, 14 gauge, whatever you might have, drill a hole in it, and then drill a real fastener, a real metal building screw through that, because it gives it enough to bite on. In standing seam roofs, it was a 24 inch or a 16 inch on a vertical leg. Mm-hmm. That was used to suck the panel laps hard together.
Yeah, and it was they were worried about the one, just bringing the two ends of the panels together in the middle of the roof, because you did need to have screws there. And once again, the idea is that we've got to have a weather tightness warranty. So the best way to do that is have another piece of metal, like Eric said, that cinch strap there to bring them together, and it helps bite the two. But yeah, I think it was 2010 that they changed all that.
I would want a cinch strap.
Long before me.
Because with a cinch strap, you don't have to worry about over tightening the screw.
Yeah, the problem with this, I think the other complaint that they were getting with the cinch straps too is that they were, it's a different material than the roof. I think it was like a 18 gauge piece of, still a piece of steel, but it had a different design to it, and it wouldn't match the color of your roof. So if you had a forest green roof, your cinch straps were silver. So you had this line of silver,
cinch straps ran on the outside.
On the outside. Yeah, they were on the outside of the roof. They weren't on the inside. They were on the outside.
Explain why people got away from them as quick as
that doesn't make sense.
Yeah, it does. Because there's the backup plate on the bottom side of the panel.
Oh, okay. So what I was referring to as a cinch strap is actually the backup plate.
Now, the backup plate is still provided. We still do, industry still uses backup plates because you do need screws. Like you said, you've got to have something for the screws to bite into. And that's where, if you're, like you said, if you've got a large enough, roof span, let's just say you've got like a single slope that's 100-foot long, that 50-foot panel, more or less in the middle, it'll have a backup plate on the bottom side. And that's the cinch strap, like Eric's talking about, that is there to help bite not only those two panels together, it sucks them all together so that they're super tight.
Okay, so it's gets it from both sides. Okay, I didn't realize that. So I call Gertz purlins, right?
Just as long as you don't call PBR roofs standing seam roofs.
Okay. Yeah.
So Customers that change the words all the time too.
So, hey, customers that, sorry.
Okay.
I was just saying customers that call in, I don't know everything. So if you want information about standing seam roof, give me a call. I'll give you Jared's cell phone number. You can call him directly.
Yeah.
We're going to put it in the comment section so that we're just call Jared.
Yeah. Goodness.
Okay, here's so the cons to a standing seam roof are basically all of the pros to a screw down roof. Right? It's more expensive. There's a lot more parts, and unless you're a large crew that installs these regularly, the install is going to be an order of magnitude more complex. They are nice, and the vertical leg standing seam roof, especially on a high pitch, man, those look good.
It looks beautiful. And I think that's the big thing with the standing seam roof too, is that getting the look that you're actually, wanting or the use out of it, right? Whereas like the trapezoidal is great for, like Eric said, earlier, a low slope industrial, you're looking for coverage and you're looking for functionality, right? That's when you're going to want that trapezoidal roof. Whereas like if you've got steep pitch, but you're concerned about like, if you've got like a 6-on-12 roof slope, you are going to be able to see that. And you're going to want, a nice clean look. And it does look really clean, like Eric said. I've seen trapezoidal roofs on a steeper slope. I would say up to a 2-on-12 where you can see the profile, and it doesn't look right. It looks weird, and it's one of those things where you can't just take it off and swap it out now that it's up there. You got to live with that. And I always try to, whenever I see some of those kind of come through on orders, like, I don't know if you really want to do that. I try to talk people out of that from making that mistake. Cause like I said, I've seen it in real life and it's like, that looks awful. It looks weirdly disproportional.
I was going to say that, but also it looks unfinished, right? It looks like, wait a minute, there's something missing. Right. There's not, it's just the nature of the product, but it looks like there's something missing. And then also like, imagine a 24-inch, 3-inch tall vertical or trapezoidal leg. A trapezoidal is like this, with Justin will give you a profile to put in the edit. The roof does not, it makes the building look small, or like And I don't know. It's like wearing your dad's suit to prom, right? It just doesn't look. It doesn't look right. Yeah.
Yeah. It's like
cute,
having. Yeah. It's having clown shoes.
Yeah.
And it's just like, why is that? And that's kind of what it is it's weirdly just disproportional. Whereas with the 16-inch architectural, like I said, I haven't seen that in a bad application, other than, industrial use. You've got a massive warehouse that you're trying to cover. And generally the erection crew wants a wider panel so you get more coverage. You can lay more roof down. You're not trying to necessarily appease your neighbors with the trapezoidal roof.
Yeah, it probably reduces the cost of labor. But I mean, I'm always surprised, other than the coating system, the Kynar finish or whatever on the 16 gauge. I mean, the cost difference between a trap roof, those parts are heavier, they're bigger, so that they cost more. But with a 16-inch roof, the architectural, you have more of them. So I think it's kind of a wash because I don't see a big difference in price.
No, I think that you're right.
Trap roofs ship a lot better. So please order trap roofs instead of, I get griped out by sales all the time. They're like, well, what do you mean I have to pay for another truck? And I'm like, well, geez, guys, I can only get about 18,000 pounds of architectural roof on a semi before it will fall over.
Yep. Right. It's more about volume when you go to ship that than it is weight.
Also, we were talking about, I don't think we need to get into thermal blocks or anything like that, but within the code, if this is important to you, not within the code, within the energy code, in some instances, there is a theory, not a theory, it's proven, it's done, but there's a lot of discussion on thermal transfer through the panel, and a through-fastener roof system, through the panel, through the screw, into the purlin, into the building system. Like, metal's very conductive when it comes to heat. So you lose a lot of, or you have the potential to lose a lot of energy through that fastening system.
Yeah. When you think about it, I was just thinking about the calculations of a building I was doing the other day, and it was just a 40 by 60, which is a very common size. There's 840 minimum screw penetrations with that. So 840 pinpricks, like Eric said, through heat transfer, that might add up to something, especially when you figure they're on average, every foot.
Mm-hmm.
Yep. Yeah. Yeah. I mean, you think these things are so tiny that they should be insignificant, but anything tiny added up over time with enough volume, talking. I mean, what do we say that we were talking about the roof on that one building was over 100,000.
Yeah, over 100,000 screws, right?
Like, I mean, it seems insignificant when you think of it on a small scale, but it's not a small scale. Over 100,000 screws is a lot of penetrations. That's significant.
And that's if you, like Eric said, that's if you did it right.
Yeah, that's if you did it right.
And there were no mistakes.
Every mistake is a new opportunity for failure.
That's right.
Yeah.
You guys keep going. I'm going to get the answer to this question.
Okay.
Someone asking us questions.
Yeah, you were saying somebody earlier today. You were talking about 94010. Before we started, you were talking about something that somebody was asking.
Yeah, it comes up pretty regularly, and I know we're talking about roofs today, not exactly trim, but a lot of people have a lot of questions about the differentiation between our sculptured trim and our regular product. Could you talk a little bit about that?
That is a good question.
Yeah, it comes up regularly enough, and it's adjacent to the topic today, but it was actually a recent question again.
Yeah, I think the sculptured trim that we have, if you get a gutter package, right, you automatically get upgraded to the sculptured trim, and basically it's just got a slightly different shape, and it helps integrate the gutter and the other end of the building, the rake end or the end wall side. It helps those two trims come together just more naturally, and it looks like they belong together.
Yeah,
Whereas-
box gutters look like hell.
Yep.
So we
And
don't do box gutters, we do sculpture.
That actually answers my next question: is can we still do our gutters with other type of trim? It sounds like we could.
Yeah,
but
you
why would we
can.
want
Yes,
to?
you
Exactly.
absolutely. Yeah, you can. It does never look good.
won't
And
look
that's
right.
one of the reasons why we don't normally offer that or suggest that, is because
Yeah.
it doesn't ever look good. You can't ever trim it out properly, and
There'd be no reason to do it.
yeah, it just
right?
looks awful.
No cost savings. It just looks weird.
No, sculpture trim's definitely more expensive. But we do offer it to any customer that wants it without an upcharge.
Gotcha.
And now if you're doing gutters, you get it for free. And what's nice about gutters and the rake and the sculptured, right? Then you can use a pre-assembled corner box without any modifications. Right. So we used to do, if you go back and you look at Keith Stefflick's video, the building, cool. It's the red building, small building. Keith and I had an interview. It's one of our first videos. He had sculptured low eave and sculptured rake. And I went ahead and he had ordered pre-assembled corner boxer. I think at that time we were just doing it on every job when they were $20 a piece. With new suppliers, they're like $65 a piece. And I'm like, no, we're not doing that. Just for anybody that wants to know why we do go cheap on some things, we don't offer, or we don't just automatically include, some of the fancier stuff, is we would have to increase the cost of the buildings. Like pre-assembled corner boxes, $65 a piece, not a big deal, right? 4 corners, right? For one job, it's what? I don't know, $240.
$50, yeah.
That's fine on that one job, I suppose. But if we did it on every job, this company will ship about 600 buildings this year. Right? That money doesn't, right? We'd have to charge for it. But if you want them, ask for them. It's awesome. But the real reason why we really changed is not because of the difficulties in modifying that corner trim with the low eave that's a non-gutter, right? The profiles still match up, but it's that top leg on the pre-assembled corner box that has to be cut, and it's never a good fit. With a gutter system, it just pops right on, and you're done. No mitering corners or doing anything like that if you have the pre-assembled corner box.
That actually answers a lot of questions I didn't even know to ask.
Well, so we went to the standard low eave flat flashing, right, which is just a 90-degree turn down with a drip edge on it. We went to that, because it's so much easier to install, and it still looks good, right? It doesn't look as good as a sculptured, but it looks good, and everybody can install it and make it look good, right?
Yeah, and there's a lot of people.
To those.
There's a lot of people with that don't want gutters, or this is just a barn. I don't need gutters for that. So and I'm going to be putting this up myself. So going with that, like Eric said, that just simple flashing makes it a lot more erector friendly. A lot less parts, a lot less pieces, a lot less trying to hold a bend, while 20 feet in the air, but my trim's bending on me. You don't have to deal with a lot of those headaches, I guess, is probably the best, way to put it. So similarly, we changed the rake trim on that too, to help match and to help kind of close off the building. There's a lot of people that don't switch out the rake trim and keep it sculptured, but kind of like Eric said, it looks unfinished. It's like, oh, cool. When are they coming back to finish that? Like, what do you mean? That's the finished product.
It's just
and it doesn't look good.
Yeah, because the box rake looks fantastic, right? There's nothing wrong with it, I don't think it looks I don't think the sculptured rake trim looks any better. Just a different profile. But again, really, it sculptured with the standard flat flashing on the eave really wouldn't jive. So we make it a box. It matches. It looks great. And that low eave trim is so much easier to install. But if you want sculpture trim, ask for it.
But that you were just reminded me when you were speaking a minute ago. There seems to be an ongoing debate about gutter straps. How many people need, how far apart? It seems to be it almost seems like people are just feeling it out for themselves. Like, even though we do have instructions and we tell people, hey, yeah, you should do it this way. It seems like a lot of people prefer, maybe, I'm pretty OCD
Right.
about things. I like to do things a little overkill sometimes. So I'm one of the customers, like if I was buying a building, that I'd put a gutter strap, like I put way too many on. Like it would be like complete overkill, but that would make me feel good,
Yeah, it's the same reason why I put washers where washers don't have to go.
Oh, 100%. Exactly the same level of OCD. Like
makes me feel good. So
yeah.
What Justin's talking about is on a pre-engineered metal building, the gutters, extend out 8 inches from the wall?
From the wall. Yeah. 8
From
inches.
the wall, and they're flat. So you have your slope coming down here, your gutters out here, right? This is about 8 inches. Reminds me of a joke, but anyways, ice and snow will come down and fill up inside of the gutter, right? There's if you get a bunch of ice and snow up there or sliding ice on the roof, it can fold the gutter over. The gutter will stay attached to the building, but it can break that edge. So we supply a gutter strap. Those go on every 3 foot, and they're installed at the lapping panel. We have done before, and it certainly would help to put them on 1 foot centers on every high rip, or I suppose on a PBU panel, which PBU panel is really not recommended for a roof, but then you can put it on 6-inch centers. The problem with that is then when you're tying in that gutter strap, you're only going through a single panel. You're not going through that mastic protected, double panel lap. So there's not much strength, right? Like that gutter strap is going to rip through that single panel with a tech screw. I suppose you could bolt it, but Lord Almighty. So instead we have the snow guard that we came up with.
Oh yeah. Yeah.
Yeah. I showed that
picture I still haven't taken yet here.
Yeah. Actually,
do you have a picture of it?
I do have a picture of it.
Awesome.
Preston. Oh gosh. Hold on.
So to be clear,
if
anyone's listening,
hold on. If anybody's listening, I'm not pulling up the picture. I might give it to Justin. But Tim Doctero was here. He did a whole shop tour. Like we were in the shop for like 3 hours, or maybe like 4. And he's going to do some like mega supercut of, he mic'd me and was like, "Hey, can I put a mic on you?" So he wanted to do like an in-depth tour into like unscripted, just like, I'm walking around talking to people. Okay. We're at an hour.
Yeah.
We've done our duty. We've done what we promised to. Sorry about last week. So we are going to have to wrap up because I do have to go and drill holes. But first, there you go, Jared.
Oh, wow.
There's grants.
28,000. Okay. 28,000.
25,000 lap techs for the roof. Nothing for the walls because it was a roof only.
Mm-hmm.
Yep. Man. Yeah, I got to see if man out there and taking just setting up a drone, just getting some good footage because that really truly, like, seeing those parts in the factory was stunning. How big some of those things were. Yeah, absolutely.
Look at this, Jared.
Yeah,
that's a big damn building.
Yeah,
yeah. I have photographs of people in the factory standing next to it, and it just dwarfs them. They're just tiny.
Yeah.
It's crazy how big these are.
All right. Well, sorry for the late start, everybody. Doesn't look like we had much for live viewers anyways, which is good. We will go back, edit this, throw some stuff in there. So if you're watching this, you should see that. My name is Eric Beavers. I will see you guys later.
My name is Jared Miller. You guys have a great week.
I'm Justin. Take care, everyone.
See you, man.